We're back with part 2 of our plasma repair video. This is the replacement board that came in. It came in with extra dust as well. Now, as you know, during the last video, we've diagnosed the Y sustain board as being defective. We found some shorted transistors and stuff in here. And I did actually look into replacing these specific transistors because I'm cheap and hey, why not try to replace the board? But unfortunately, these specific transistors, these are IGBT pulse transistors, they were made for exactly one application. These things were made for plasma display panel applications, and because plasma panels kind of went out the wayside, these transistors went out the wayside. They haven't been manufactured in a lot of years, and you cannot get them anymore. Now I do have some generic replacements. I've got this, you can't see it. This is an RJH3077, which is another plasma display panel IGBT driver, which may or may not be compatible. And if this was the last TV on Earth and the last board on Earth, I might consider actually trying to substitute this transistor in there and repairing everything else that's run on that board and trying to get it going again. But it is somewhat risky, so I decided I would treat myself, and for about $60 I bought a replacement board. One thing I noticed right away when I got this board is that even though it's exactly the same board, it's got the same part number, same revision number, same everything else, I noticed that this board has a weird kind of white square here, whereas these are solid black. And I think the reason this is white and this is kind of gray here and this is all black is I bet you this was installed in a TV set that was facing the sun, and every day the sun just came in through the ventilation holes on the back and just kind of erased the bluing right off the metal. And you can see how it's a little bit less intense as you go out, because I think like as the sun moved, the angle would lessen, and so you would get this fade out. That's my theory as to why this looks so strange. One thing that's peculiar about plasma TVs is that they do put in all these pots. There's 3 just on this board all over the TV, and these pots generally adjust voltages. Now, in this modern day of age, you think that this would all be done digitally, but in plasma TVs, they're pretty old school for some reason. They have all these pots, and these pots, they need to be tuned to the specific panel and I presume the specific board. If you have a really big mismatch between what these pots are set to and how that particular panel that you have is manufactured, it can cause a lot of problems. In this particular board, we have 3 of these pots. Let's take a close look. Now, I've been doing a lot of research and reading up on what these pots exactly do. This one is called VRRR. So with plasma TVs, when a pixel needs to go from black to white, there's a very specific waveform that this board generates, and that waveform has to look a certain way, has to have a certain duration. And what VRRR does, RR means rising ramp. So the ramp up voltage, the ramp up waveform I should say, is actually changed by this pot, and this has to be matched to the specific panel. If you mismatch this, then you get pixel misfires, you get possible arcing on the screen, things like that. And over here we have one additional pot. This pot is used for when a pixel needs to go from white to black. This is called the FR, or falling ramp, and again that waveform has to conform to a specific shape and timing, or else it creates all sorts of issues with the screen. Finally, on this board, we have one more pot. This is called the V-scan. So this actually sets up a real voltage on the board. It doesn't just alter the waveforms. And this is sets up a negative bias on the screen. I think on this TV it's like minus 193 volts or something like that. This is essentially sets the black level of the TV. It also sets the gamma of the TV. Now, I've been comparing the pot positions of this board and the replacement board, and they're actually pretty close to each other. So I think what I'm going to do is I'm going to install it. I'm going to install this board as is. I'm not going to tweak anything on it, and we'll just see what the picture quality is like. And if there is some tweaking that has to be done, we'll do a little bit of tweaking to bring these pots closer to what they are on this one, and hopefully that's enough to get the TV set basically to a serviceable condition. Now, one thing I found particular while I was researching what all these different things mean is that I guess back in the day around 2010, 2012, when plasmas were a big deal, what a lot of enthusiasts used to do is they would buy these plasma TVs. They would actually remove the back off the TV, and then they would go in and they would twiddle with all these little pots and adjustment and move things up and down. And the point of doing that was to just improve the black level of the TV and just get a little bit more performance out of the panel. For me, I would never play with them, but some people do, just to eke out that extra bit of performance. I also want to say that this is the TV's last shot. If this does not work, if the set just blows up again, then I'm not going to try and fix it again. I'm just going to go and shop for a new TV, which I kind of already have been. But I'm not going to try this again twice if this board blows, that's for sure. Okay, well, we are just about ready to power up. I've got the board in there. I've got my multimeter and mirror set up, remote set up, second camera set up in case something interesting happens. I've got my high voltage safety glasses on. I've got my high voltage gloves, high voltage underwear. Should be okay. So I'm going to turn on mains power right now. Okay, there we go. And then I'm going to turn on the TV. Now what I'm going to do is I'm going to set the TV to service mode. So to do that, I'm going to hit mute 182 power. Actually, I don't need to. The screen came on immediately as soon as I just turned it on. That's kind of neat. It didn't blow up in my face. How unusual. Okay, good. We are in the service menu right now. So what I really want to see, so one thing that's really interesting is panel display time. I'm going to bring you guys right in here so you can actually see it. You can see I've gotten a whopping 4546, so I've never even gotten 5,000 hours out of this panel before it blew up. Wow, that is a really, really low number. That's just sad. Yeah, to me the panel looks fine. Like, I'm not going to adjust or touch any of those pots back there. I tested the voltage. It's supposed to be minus 193. It's about minus 192 volts for the V-scan voltage, so I'm just not even going to touch that. And everything else, you know, we've got a perfect grid pattern here, no problem. Our colors look perfect to me. I mean, I'm not really an expert, but they look fine to me. There we go. So yeah, this panel looks like it's doing just fine. Like, there is like literally nothing wrong with any of this. I'm a bit disappointed that this TV didn't even make it to 5,000 hours of operating time before it blew up. I mean, I've seen these when I used to work on them. These TVs used to go to 50,000 hours by the time I got them, and they weren't working anymore. This one made it to what, 5,000 hours? Like, are you kidding me? Now I'm going to check the V-scan voltage just to show you guys. And yeah, it's supposed to be minus 193. It's about minus 191, so I'll live with it. Let's check our VS voltage while we're in here. It's supposed to be 211 volts, 211.4. Okay, so don't think I'm gonna mess with that. VA voltage, VA voltage is right here on the power supply. You can see the test point there. Now I have to probe that really carefully because it's right next to a capacitor and two jumpers, so we don't want to short that out. VA voltage is supposed to be 55 volts, and we're at 55 volts. So the voltages on this set are just absolutely perfect. They really are. By the way, with the moving test pattern, our power consumption is at a healthy 255 watts. Okay, that weird white bar is only on the camera. Okay, I didn't realize this TV made weird ding sounds. I must have defaulted that. Okay, HDMI, looking for signals, okay. And we should be able, there we go. And guys, I know on camera it looks bad. You see a really weird bar. However, that is only an effect on the camera. In real life, the TV picture looks absolutely perfect. I've been using the LCD TV I got from the guest room for the past like 4 weeks or something like that. And it is so nice to get back to a plasma display. It is such a better image. It is softer, crisper, sharper, less sharp, and just better colors, better saturation, more realistic. It's just a better picture than LCD in every way. In every way, it's better. Not in every way though, to be honest with you. Plasmas do have their drawbacks, okay? They're really bad for image retention. They have trouble with certain types of images and so on and so forth. Okay, it's not the perfect display technology, I'll admit it. but damn it, it looks good. And I'm so glad I was actually able to fix it and save this TV and do it for only 70 bucks versus running out and spending $700 or $800 on a brand new TV. So that's going to be it for this video. Thanks for watching. We'll catch you next time.